Calculus BC, we are in lesson 3.6. We are going to be taking derivatives implicitly. Implicit differentiation is the name of the game today. That's our learning target. First of all, a review from the last lesson, the chain rule. What if your inner composition, the inside function, was unspecified? What if it was written just as f of x? Say, how do I take the derivative? Well, you'd bring your 4 down, the derivative of the outside, raise that up, subtract a 1, you've got that to the third power, multiply through by the derivative of the inside. And there you go. And usually, I think when kids look at it this way, they correctly will say, well, yeah, that's just what's happening with the chain rule. Now imagine if you had a relative or a friend who was just starting algebra. They're in Algebra 1, and they were absent and they needed some help, and they came up to you and said, oh, wow, maybe you can help me out. My teacher taught us a lesson, and I saw the notes, and it looks really confusing. There's all this f of x stuff. Well, f of x, you would tell your friend or relative, f of x is really just another name for y. And then we'd say, well, how do I take this derivative of y, a function of x? Well, just what you did right here. The derivative of the outside, bring down that 4, subtract a 1, and then you'd say multiply through by the derivative of the inside. The derivative of the inside we'd write as dy dx. And guys, that's what implicit differentiation is all about. We're assuming that y is a function of x, and we're going to take the derivative via the chain rule. So let's take a look at example 1. We have 5x squared minus 4y squared equals 10. They want us to find y prime. The derivative of 5x squared is a 10x. Be careful here. This is really like a minus 4y. You could think of that y as if it were f of x, right? Bring down the 2. 2 times 4, that's an 8. Then you'd have y to the first, but then you will have a derivative of the inside. That's your dy dx. The right side over here, the derivative of 10, that's a constant. That's just going to be a 0. So they want you to find y prime or find dy dx. Tell you what, I'm going to add this 8y dy dx over here. And then I'm going to divide both sides by 8y. And your tangent line slope, dy dx, 10x over 8y, I'm going to divide out a 2. I'm going to reduce my fraction here. And there you have it. So in other words, we found the tangent line slope to whatever this curve would look like. Right now, to find the tangent line slope, of course, we would have to substitute in not just the x-coordinate of the point of the ordered pair, but also the y-coordinate. Hope that's making sense. Let's go to the back page here. It says, find the slope of the normal line to sine of x, y squared plus 4y equals 12 at a particular point, 0, 3. I tell you what, I'm going to call this method 1. I'm going to show you another method in a little bit. Method 1, we're just going to proceed exactly how we have on the front, and we'll just start off with the product rule. Remember the product rule, guys. It's u times v. If you're taking the derivative, it's uv prime plus u prime v. So this derivative, we'd have a u, and then we need our v prime. Well, what's the derivative of y squared? Well, it's going to be 2y, chain rule now, dy dx. So that's your u, v prime. But now I need a u prime. What's the derivative of sine of x? Well, it's cosine of x and my v is just y squared. Now don't forget, you also should take the derivative of 4y. Well, that's 4 dy dx, and then the derivative of 12 is just a 0. So it's at this point, guys, where I do want to just help you out a little bit in terms of solving. I'm going to, first of all, point out to you that we don't have just one dy dx, we actually have two of them. So what we'll do here is I'm going to bring this cosine x y squared to the right-hand side. When you change sides, you change signs. Now, I'll tell you what, I'm going to put the y squared out in front, just so that no one would ever mistake the y squared for being inside of the cosine function. And then over here, likewise, I'm going to bring the 2y out in front. And then we have a 4 dy dx right here. And wow, we are almost done. We're so very, very close to being finished here. With this dy dx, we need to solve for that. I'm going to factor out a dy dx, undistribute that if you would. You can always double check that you're right by redistributing, remultiplying that in. And then what? Trying to get my dy dx alone, I'm just going to divide both sides. By that parenthesis right there. Okay? So there you have it. That's your derivative. What they're actually asking for, though, is the slope of this normal line. Now, guys, real quickly, just want to show you that we are interested in plugging in the point 0, 3. Now, when you do that, you'll have a negative 3 squared cosine of 0. Down here, 2 times 3 sine of 0 plus 4. I hope you remember that the cosine of 0 is a 1. The sine of 0 is a 0. So we're going to be left with a negative 9. 3 squared is a 9. And this whole thing multiplies to 0. That wipes out, except we're going to have a 4. So the slope of the tangent line is negative 9/4. The slope of the normal line is going to be the opposite reciprocal, which is going to be a positive 4/9. Okay? Now, you might have noticed that I wrote method 1 and then method 2. And, method 1, I didn't even write method 2 just yet. Sorry about that. But take a look at this. Method 1, you'd say, well, is there another method? Yeah, tell you what, I'm going to just sneak over here and recopy. Method 2 would start exactly the same way, guys. Exactly the same way. You still have to take that derivative. There is no getting around that. So that begs the question, what in the world are we doing here? Tell you what, you know that you're going to have to plug in 0, 3 at some point. You could plug it in now. You could say, well, what's the sine of 0? Well, wow, the sine of 0 is 0. Right here, we'd get the cosine of 0 times the 3 squared, and here's a 4 dy dx. What am I getting at? Sine of 0 is 0. That completely goes away. The cosine of 0 is a 1, so we'd have 3 squared, that's a 9. Look at that. We'll just real quickly subtract a 9, divide by 4, And now you can see you'd have the same tangent line slope. So look, if you know that you have to plug in a point, 0, 3, you have the option of doing that much earlier. Now, I can't stress enough the importance right here, however. So very often you won't be asked to necessarily plug in a point. You might just have to solve for the derivative, and you will have to factor out a dy dx. But I just wanted to show you that you do have freedom when you have a point. You can plug that point in early, and it might make your life a little bit easier. Well, hope this is going well for you. Best of luck to you.